Let's look at Chapter 4, Lesson 1 Extension, Introducing Angles. For 1 and 2, tell how many players could use the spinner in a fair game if each letter or color gives one player a point. Explain how each number of players could use the spinner. So I need to look at this to figure out how many players I'm going to start with. And since I know I need players, I know I'm going to need more than one. So let's see if I can divide number 1 into 2 pieces that are fair. If I split it down the middle, I know that each player would have 1, 2, 3, 4, 5, 6 pieces. And since each player would have 6 pieces, that means that having 2 players play would be fair. So I'm going to write 2 players would equal 6 spots each. Then let's see if 3 can. If I know that I have 12 pieces altogether, can I divide 12 evenly by 3? And I know that 12 can evenly be divided by 3 with each player getting 4. So I know that 3 play would equal 4 spots. Now let's try to have equal play with 4 players. If I know that I have 12 pieces, can 12 be divided evenly into 4 different? And I know that I can divide it evenly so that each player would get 3 spots. So if 4 play, it equals 3 spots. Now let's think about if I can get 5 to go into 12 evenly. And I know that 5 times 2 is 10, and 5 times 3 is 15, so no, 5 cannot go in evenly. Let's think about another number, 6. Can 6 go into 12 evenly? And yes, I know that 6 goes into 12 2 times, so each player would get 2 different spots. So then I would write, if there's 6 play, it equals 2 spots. Let's look at number 2. Count how many pieces you have. 1, 2, 3, 4, 5, 6, 7. If I know that I have 7, then I'm going to be able to figure out how many players will be able to play evenly. I first need to think about which numbers go into 7 evenly, and I know that 1 will go into 7 evenly, and I know that it goes in 7 times. But I need more than 1 player, so 1 can't be used. 2 does not go into 7 evenly because 7 is an odd number. 3 does not go in evenly. I could have 2 times 3, which would be 6, or 3 times 3, which would be 9, and neither of those equals 7. 4 does not go in evenly because 4 times 1 is 4, and 4 times 2 is 8. Neither equals 7. 5 does not go in evenly either because either you would have 5 times 1 is 5, or 2 times 5 is 10. 6 does not go in evenly either. You have 6 times 1 is 6, or 6 times 2 is 12. That's too high. 7 does go into 7 evenly, and it goes in 1 time. So for this game, each person would get just 1 piece. So you would need to have 7 players get 1 piece each, or 1 spot. Let's move on to 3 and 4, where we need to complete the spinner so that it could be used in a fair game by the number of players named. So I know that I'm going to have 5 players, but it can't have 2 players. So I need to think of a number that 5 can go into, but 2 does not go into. So first off, I know that 5 goes into 5 evenly. So I could split this up into 5 different pieces that are even. Now that's just one way. I could also go ahead and think of another number that 5 goes into that 2 does not go into. And I know that 5 goes into 10, but so does 2 evenly. I know that 5 goes into 15, and since 15 is an odd number, 2 does not go into it. Unfortunately, though, this spinner is so small, it wouldn't make sense to cut it up into 15 pieces. So I know logically that I should stick with a spinner that has 5 pieces, so that I have 5 players, and each player gets 1 piece. Let's look at number 4, where we have 3 players but not 2 players. So I need to think of a number that 3 can go into but 2 does not go into. So I know that any number that 3 goes into that is even should not be part of my spinner choices, because if 2 goes into it, that means that I'm not following the rule here, that it should be 3 players but not 2. So thinking about that, I know that 3 goes into the number 3 evenly. So I could have a board that has 3 different pieces, and each person would get 1 piece. And then the next multiple of 3 is 6. But I know 6 is even, so that means 2 goes into it, which means that cannot be a choice. And another multiple of 3 is 9. 9 is not even, so it follows the rule. But 9 would make it a little bit challenging to draw. I could go ahead and have something that looks like this, and then chop it into 2 more pieces. So then I have 9 pieces, and each person would get 3 different pieces if there was a spinner there. So realistically, this could either be cut into 3 pieces or 9 pieces.